So, in today's lecture, I'll tell you about the basic principle of the three-phase induction motor. In three-phase induction motor, there are two parts as for the every motor. One is the stator and one is the rotor. Stator is the stationary part and rotor is the rotating part. Okay. In the stator, we will give three-phase supply, as they have mentioned that this is a three-phase induction motor. Three-phase supply means we are giving the three wires means we have given the three supply like this. One is for red, one waveform starts from the zero, another is for the yellow, suppose yellow waveform starts from the positive, another is for the blue, suppose blue waveform starts from the negative side. Like this, it is RYB supply. If you'll consider that this positive supply starts from here, okay, this R supply starts from here, this zero supply starts from here, and this B supply starts from here. Okay, so this is for R, this is for Y, and this is for B. So at this particular point, you can see that all these are not starting with the same point. All these not starting with the same time, right? First, like suppose you are a three members. Okay, you are three member. One is Aaron, one is Darren, and one is of your friend. So first, this one is R, this one is wife, this one is B. First, R goes into the room. Okay, then Y goes into the room, then B goes into the room. Okay, clear this thing? Now suppose these three friends are standing like in a circular position. Okay, so in this case, first R moves. This one is R. First R moves, then Y moves, then B moves, right? So all these nodes are starting at the same time. First there is a movement of R, then there is a movement of Y, and then there is a movement of B. And as you know that if there is a wire and there is a current flowing in that wire, then it produces what? Magnetic field. Will it produce magnetic field? You have studied now that a current carrying wire, current, this is a wire, this is a current carrying wire, always produces a magnetic field. So this R, Y and B are, these are also the wire, these also producing a magnetic field, right? So first in the current, first current will flow in the R wire, so it is producing magnetic field. Suppose it is producing here, then the current flows in the wire, it is also producing magnetic fields, it is suppose here. Now the current flows in the B wire, then it is also producing magnetic field. Okay, if the currents are rotating, like first current goes to R, then Y, then B, then their magnetic field also rotates, because if the current is rotating, first R goes, then Y goes, then B goes, again then R goes, then Y goes, then B goes. So the magnetic field produced by these three wire will also be in the form of rotating magnetic field. As you know that we can't see the magnetic field, right? We can just imagine that there is a magnetic field, but we can't see the magnetic field. That's why we can't say, but there is a rotating magnetic field. That concept is known as RMF. RMF means the rotating magnetic field. This is the most important concept for the principle of three-phase induction motor. Now you understood what is RMF, because you will generally read from the book that there is a concept of RMF. They won't explain you that what is RMF. RMF is the rotating magnetic field, means the wire current is rotating across it, so the magnetic field produces by the current, that is also rotating. Clear this thing? So this is the induction motor, this is the diagram for the induction motor, and we have given RYB supply, means there is a current in the RYB, so it is also producing magnetic field. So it is producing which field? Rotating magnetic field. Now you have to use your imagination power, that there is a magnetic field and that is known as rotating magnetic field, that is magnetic field is rotating around the stator. Okay, as you know that magnetic field we can't see, so we can't see any field, we can't see anything that which is moving. We can just imagine that if we'll give the three-phase supply, that then in that case magnetic field keeps on rotating around the stator. Clear this thing? But rotor is still stationary. It's, for now being, rotor is still stationary, right? Clear this thing? We have given supply to the three phase AC. We have given supply three phase AC to the stator, and this three phase supply producing rotating magnetic field around the stator, and still rotor is not getting EMF. Now you know the one, you know one concept, that if there is a magnet around it, one is the north magnet and one is the south magnet, and there is a coil. If we placed it around the magnet, what will happen in this case? Either will rotate the coil. In this case, we generally, what will happen, will rotate the coil, right? If we'll rotate the coil, then it will cut the magnetic field lines or not? Tell me. If we'll, like by your hand you are rotating this coil, will it cut the magnetic field lines or not? These are the magnetic field lines. It will cut or not? It will cut. So according to the Faraday's law of electromagnetic induction, he says that dE is equal to minus n d phi by dt, means if there is a change in flux, if there is a change in flux with respect to time, okay, if there is a change in flux with respect to time, then in that case EMF will induce. If the magnetic field lines will cut, then flux will cut, right? Magnetic field lines are indirectly is equal to the flux only. If magnetic field lines will cut, then in that case flux will cut, and if flux will cut, then in that case flux will change also. Okay, there are many things. There is a imaginary magnetic field lines, and we are rotating this coil. If we are rotating this coil, then in that case magnetic field lines will cut and magnetic field lines will change. So flux will change, and after there is a change in flux, then in that case EMF is induced. EMF means we are generating with the voltage. Okay, now in this case current is moving in this coil. EMF means voltage is generating and voltage means current is flowing. So in this case current is moving in this coil. Okay, understood this concept? But now for the while being, like in this case what we have done, we have done the opposite case. Opposite means in this case coil is stationary. Okay, coil is stationary, but what we had done, we are rotating the magnet. What we are doing, we are rotating this magnet. So tell me, if we are rotating this magnet, then in that case flux will cut, flux will, field lines will cut or not? It is completely opposite to the previous case. In this case we are rotating the coil, but the magnetic field are stationary. But in this case magnetic field are stationary, but we are rotating the coil. So tell me, if we are rotating the magnetic field and coil is stationary, so the field lines will cut or not? Coil is stationary, okay, and we are rotating the magnetic field line, magnetic field. So field lines cut. In this case coil is moving and it is cutting the field lines, okay, but in this case coil is stationary and we are rotating the, it will cut, right? And if field lines will cut, it will change, right? Obviously if it will cut, it will change. If it will cut, it will change, then in that case flux will change. And according to Faraday law, if flux will change, then there is a production of EMF. Okay, there is a production of EMF, means in this case current is flowing. In this case current is flowing in the coil. So this, remember this concept and compare that concept with this concept. Now you can see that this rotating magnetic fields are moving, correct? Means magnetic fields are moving, and in between coil is stationary, right? So magnetic field will, lines will cut and magnetic field lines will change. So in that case flux will change. So the current is induced in the rotor, current is induced in the coil. Okay, understood up to here? So now tell me, you are giving which energy to the motor? We are giving electrical energy or we are giving mechanical energy to the induction motor? This RYB supply is the electrical energy, na? Hmm? This RYB supply is the electrical energy that we are giving to the stator, and what we are getting from the rotor? Electrical energy or mechanical energy? I said that No, till now electrical energy is there. I said that current is induced means EMF is induced in the rotor, and if EMF is induced in the rotor, then in that case current will produce, right? So we are giving also electrical energy, we are getting also electrical energy. But what is the function of motor? That is, motor converts electrical energy to the mechanical energy. Correct. Till now rotor is still stationary, rotor is doesn't start moving. Okay, up to here. Now after that what will happen, you can see that there is a current flowing in the rotor. So if current is there, it will produce magnetic field. Will it produce magnetic field or not? If current is there in a wire, then it will always produces magnetic field. And there is a rotating magnetic field in the stator, there is a magnetic field in the rotor. If there are two magnetic field, one is in the stator and one is in the rotor, will these two magnetic field will interact with each other or not? Suppose here north pole is generated and here south pole is generated. So will these two attract with attract with each other or not? Tell me. Hmm? Will these two magnetic field interact with each other? Because here in the stator we are having rotating magnetic field concept, and in the rotor we are having current, and due to that current magnetic field is produced. So in this case magnetic field is generated. So these two magnetic field will interact with each other. If it will interact with each other, then in that case rotor starts rotating. Okay, rotor starts rotating. If stator is moving in the clockwise direction, then rotor is also moving in the clockwise direction. This is how the three-phase induction motor works. Okay, I'm telling you from the starting, like we are having two things only. One is the stator, outer one is the stator, and inner one is the rotor. Okay, now we have given three phase supply to the stator, that is R, Y, B. Due to this three phase supply, first current flows through R, then it produces magnetic field here, then current produces through Y, then it produces magnetic field here, then current will flow through the B, then it produces magnetic field here. Because both are moving, all are moving not in the same time, so it will look like that magnetic field is moving, and it generates the concept of RMF. RMF means the rotating magnetic field. Okay, so due to this three phase supply, current is there, due to this three phase supply, rotating magnetic field is generated. If we'll use single phase supply, then in that case RMF concept will not be there. Okay, now there is a coil in the, as in the form of rotor, but this coil is still stationary, it is not start moving. So as we see that if we'll put any coil, stationary coil, in the magnetic field, in the rotating magnetic field, then lines will be generated and flux line will be cut. So due to the change in flux, according to the Faraday's law, there is a change in flux because RMF is magnetic field is rotating. There is a change in flux, then EMF will induced in the stator. So this EMF will induce in the stator means the current is flowing in the rotor. Okay, now the current is flowing in the rotor, but still rotor is stationary, still rotor does not starts rotating. Okay, now if there is a current, then in that case there will be magnetic field also. If there is a magnetic field, then in that case there will be current also. So current is producing in the stator, it is producing magnetic field. Okay, it is producing magnetic field. So in the stator we are having RMF, and in the rotor also we are having magnetic field. So these two magnetic field will interact with each other, right? Suppose north is here and south is here, so south will attract with the north. Stator can't move because stator is stationary, so what will move? Rotor. Rotor starts flowing the stator. If north will come here, then south will follow again the north. That's why if stator is moving in the clockwise direction, then rotor also starts in the clockwise direction. Understood? Understood this concept? Now we are having two types of speed. One is the stator speed, that is denoted by the ns, and one is the rotor speed, that is denoted by nr. So we are having difference in speed that is generated by the slip, that is ns minus nr divided by ns. Okay.